Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on August 14, 2025, just 4 days ago. The standout result is a synthetic data pipeline that breaks the data wall, delivering up to 7.7 times faster training than open web data, while outperforming state-of-the-art synthetics sets by as much as 5.1 percentage points across 14 benchmarks. The paper is titled BeyondWeb: Lessons from Scaling Synthetic Data for Trillion-Scale Pretraining, and the implications for model training are quite significant. In short, targeted source rephrasing beats naive scaling, with strong gains from information density, seed quality, and diverse generation strategies. Building on that, posts highlight the data wall message, celebrate 3 billion models beating 8 billion models in a new Pareto frontier, discuss diversity and rephrasing, and question scaling beyond 2 trillion tokens. Engagement is moderate. Alright, this figure has 2 panels. On the left, accuracy rises with model size, and the blue points define a new accuracy efficiency frontier, where the 3 billion setup lands near 60.8% and even challenges 8 billion baselines. Moving to the right panel, the blue training curve climbs to the mid-63s by 180 billion tokens, reaching baseline accuracies much sooner, with labeled speedups of 7.7 times over Red Pajama and 2.7 times over Nemotron-Synth. Next up, the big results table compares datasets across 14 benchmarks at 3 model scales. Focus on the shaded cells. Those show consistent wins, with the BeyondWeb mix topping the average at each scale. At 1 billion with 1 trillion tokens, the average reaches 57.4. At 3 billion with 180 billion tokens, it climbs to 60.8. At 8 billion, it reaches 63.7. These gains appear across tasks like MMLU, PIQA, SciQ, and race, not just a few. Now, this line chart compares 3 strategies against the web baseline. Focus on the full plot area. The blue curve, BeyondWeb, rises fastest and peaks near 50.4%. The yellow curve, Cosmopedia, trails slightly around 47%. The cyan curve, Simple Summaries, closely tracks yellow at roughly 46 to 47%. The gray baseline sits lowest. Taken together, the near overlap of yellow and cyan shows that increasing token information density, even with basic summarization, captures most of the generator-driven gains. Staying with the augmentation story, this chart tracks average accuracy versus tokens seen, and the dark blue curve jumps out early. The blue line quickly climbs past 48 and finishes near 50.4%, clearing the others by a wide margin. The 2 lighter curves, continuation and the full data upper bound, both level off around 46.2%. The gray repeat baseline lags near 45.5. The 4.2 percentage point gap makes the case that intentional rephrasing, not mere repetition or naive continuation, breaks the data wall. Continuing the results, this bar chart stacks 3 panels for 1 billion, 3 billion, and 8 billion models. The blue bars lead in every panel, landing at 57.4, 60.8, and 63.7% respectively. The green bars, Nemotron-Synth, come second, while yellow Cosmopedia and gray QA-Wrap trail. The red web baseline sits lowest. The takeaway is clear. The same token budgets deliver higher average accuracy when the data is rephrased and diversified, with especially large gains at smaller scales. Building on that frontier, 2 takeaways stand out. First, targeted rephrasing creates denser tokens that break the data wall, delivering faster training and higher accuracy than raw web or naive continuations. Second, diversity across rephrasing strategies sustains gains over long runs. Data wall means diminishing returns from simply adding more web text. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.